Okay, so now that we had some practice on applying the quotient rule, let's move on to some exam questions. Alright, so let's have a look at this first exam question. We have y equals to 5x squared plus 10 on the numerator and x plus 1 all squared on the denominator. Show that dy dx is equal to this expression here, where a is a constant and the power of the bracket here is also a constant to be determined. So let's start off by labeling the numerator as u and the denominator as v. So let's write them out separately. So we have u equals to 5x squared plus 10x. So we have u dash equals to 10x plus 10. V equals to x plus 1 all squared. If we now differentiate using the chain rule, we get v dash equals to 2 bracket x plus 1 to the power 1 times by differentiation of x is 1, and that just simplifies to, well, when you times on 1, no, it's not needed, and that power 1 is not needed, so expression is bracket 2x plus 1. So let's substitute these into our expression for the quotient rule. So therefore dy by dx is equal to u dash v, that's u dash times by v. So we have bracket 10x plus 10 multiplied by bracket x plus 1 all squared minus u v dash, so that's u here, so bracket 5x squared plus 10x times v dash, which is 2 multiplied by x plus 1 close bracket all over v squared. So that's going to be x plus 1 squared followed by another squared, so multiply the powers, so we get a power of 4. Before we carry on, so I want to express the use of brackets in this formula here. I've seen that a lot of times some students leave out the brackets when they're connecting, when they're combining the u dashes and the v's and so on. And what they don't realize is that the bracket is really needed, because when you have to multiply the brackets out, all the terms in the bracket is multiplied by what's outside the bracket, and without the brackets, you can make those common mistakes by not fully expanding the brackets out. All right, so bit of advice, you might be tempted to expand all the expressions and then simplify. It will get really messy if you do so. Just compare what you have with what you have to get to. The denominator is already in that form, so keep it as it is. The numerator, yes, it does need to get simplified, but do they have anything common with the denominator? And we can see that they both have x plus 1 as a common factor. So just like what we did in the previous examples, once you have the initial expression, see if you can cancel any terms or any factors out. So here we can divide the numerator and the denominator by the bracket x plus 1. Okay, so we're going to cancel off the x plus 1 from both numerator and denominator. So that cancelled off. Divide this by x plus 1 will knock off the power, turn it into power 1, and then knocks off the power 4 and makes it power 3. So the numerator is now basically an expansion of those two brackets minus the expansion of 2 times this bracket, and everything over the x plus 1 all to power 3. So expand this bracket here, so we have 10 times x, or 10x times x is 10x squared. We have 10x times 1, so that's 10x. We got 10 times x again, so that's 10x. We got 10 times 1, which is 10. Subtract. So we have 2 times 5x squared, so that's 10x squared. And we got minus 2 times 10x, that's minus 20x. All over our x plus 1 to the power 3. And now if you look on the numerator, we have the 10x squared cancel the minus 10x squared. And we have the 10x plus 10x, which cancels the minus 20x on this side. And you can see now, all we have left is 10 over x plus 1 to the power 3. And compare that with the final form. A is therefore equal to 10 and n is equal to 3. So let's have a look at the second exam question. We have y equals to 3 sine theta over 2 sine theta plus 2 cos theta. Show that dy dx is equal to a over 1 plus sine 2 theta, where a is a rational constant. Now this, if you will notice, is very similar to the layout of the previous question we just done. So again, A is the constant that needs to be determined. If you look here, that we have sine thetas. Here we have sine 2 theta. As a hint, that double angle will be needed at some point. So let's get started. So U is the numerator. So U is equal to 3 sine theta. U dash is equal to 3 cos theta. V is equal to 2 sine theta plus 2 cos theta. Therefore, V dash is equal to 2 cos theta minus 2 sine theta, because cos differentiates into a minus sine. Okay, so let's substitute our expressions into the quotient rule. So we have dy by dx is equal to u dash v. So u dash times v. Again, simplify as we go along. So we get 6 cos theta bracket sine theta plus cos theta. You can see that I've actually factorized the 2 out and times by the 3, and we're left with cos and the bracket which contains the sine plus the cos minus u v dash. So that's u and that's v dash. Again, we can factorize the 2 out and times by the 3. It will give us a 6 sine theta bracket, and we're left with cos theta minus sine theta all over v squared. So that's going to be 2 sine theta plus 2 cos theta all squared. Okay, so let's see what happens now. Expand out the bracket. So you get 6 cos theta times sine theta. That gives us 6 sine theta cos theta plus 6 cos theta times cos. So that times that and that times that. We have 6 cos squared theta. So then we have minus 6 sine times cos gives you minus 6 sine theta cos theta. And a minus 6 sine times a minus sine, which gives you a positive 6 sine squared theta, all divided by, so the denominator we have 2 sine theta plus 2 cos theta all squared. Now the numerator, let's see if we can tidy this up. We have 6 sine cos and we got minus 6 sine cos, so obviously that cancels this off. We also have 6 cos squared plus 6 sine squared. Right, so if we factorize the 6 out from the numerator, we'll be left with cos squared theta plus sine squared theta. Okay, and from your identity, you know that cos squared plus sine squared equals to 1. So this is basically going to be equal to 6. And over the same denominator of 2 sine theta plus 2 cos theta all squared. So now let's compare this with what we have here. We have a constant of the numerator which is needed. Okay, a may be equal to 6 or it may not be 6, but at least we have a constant. But the denominator looks different. Okay, so we have to do more here to make it look like this expression there. So my first step would be, okay, so we've got a bracket here and being powered 2. There's no brackets there. So maybe we have to expand this bracket, see where that takes us to. So let's expand the denominator. So we have 6 over, so just a bracket square, so it'll be 2 sine theta times 2 sine theta. That's 4 sine squared theta. We have 2 sine theta times 2 cos theta, which gives us 4 sine theta cos theta. And then we'll have another lot of 2 cos and 2 sine, which will make this 8 altogether. Plus, and then 2 cos times 2 cos, that's 4 cos squared theta. Again, you can see there's a long expression of what we have on the denominator. Again, factorize that the 4 from the cos squared and sine squared. And I'm just going to do that on the side here, because otherwise I'm going to run out of space. If we factorize the 4 from the cos squared and sine squared, you'll get 4 bracket cos squared theta plus sine squared theta, when cos squared sine squared is 1, therefore this is equal to 4. In other words, those two terms are just going to add up to give you 4. This will be equal to 6 over, so 4 sine squared plus 4 cos squared, as we can see here, is just 4. So you have 4 plus 8 sine theta cos theta, which is equal to 6 over. Now here we have sine cos, but here we have sine 2 theta. We know that sine 2 theta, it's right here, sine 2 theta is equal to 2 times sine theta cos theta. But what we have 8 lots of sine theta cos theta. So an 8 we remember can be written as 4 times 2. So we have a 4 here. So factorize the 4 out, and we'll have 1 plus 2 sine cos, and 2 sine cos is equal to sine 2 theta. All right, so let's just explain one more time. Factorize the 4 from this expression here. So we have, take the 4 out, and we have 1. So this becomes 1 plus, then we'll have 2 times sine cos, and then here 2 sine cos, you can replace that with sine 2 theta. And finally, we now have 1 plus sine 2 theta here. 6 over 4, or 6 divided by 4 is equal to 3 over 2, bracket 1 plus sine 2 theta. Okay, so if we now compare that with the final answer here, so you can see that our A is equal to 3 over 2, which is a rational constant. Okay, so let's have a look at the last exam question I have for you. You might want to try this question out yourself first, so pause the video, and when you're ready, press play. Okay, so there is actually 2 parts to this question. Part A is show that if you differentiate this expression here, you get this answer there. So even though you're given the answer, it's very important that the fact that it says show, avoid jumping steps and just show all the little bits in between. So by looking at this expression here, we can see that u is equal to 3 plus sine 2x. So u dash would be equal to 2 cos 2x. V is equal to 2 plus cos 2x. So v dash is equal to minus 2 sine 2x, because differentiates into a negative sign. So we now say dy by dx is equal to, again, now because this is a show question, I would advise to copy the formula out for the quotient rule, as we need to show all the steps. So that's u dash v minus u v dash over v squared. And with this expression on the side, substitute them in. So u dash times v. So we have 2 cos 2x multiplied by 2 plus cos 2x minus u v dash. So u times v dash. V dash is already negative. We'll make this a plus 2 sine 2x. And we have our 3 plus sine 2x. All over v squared. V is 2 plus cos 2x, and all of it gets squared. All right, so you can see here that we already have the denominator as what we need to. All we have to do is just expand and simplify the numerator to make match with what we have on the top. So expand the bracket here. So we have 4 cos 2x. So that times that, and that times that gives us plus 2 cos squared of 2x plus 2 sine times 3 gives us 6 sine of 2x, and then 2 sine times another sine, that's plus 2 sine squared of 2x, all over the same denominator of 2 plus cos 2x all squared. Now we can see that we have 2 cos squared 2x, and we have 2 sine squared 2x. So just like in the previous question we saw, we have 2 sine squared of 2x plus 2 cos squared of 2x. Factorize the 2 out, and we have sine squared 2x plus cos squared 2x. It doesn't matter. It doesn't matter that we need those angles to be the same, but the fact that we have sine squared plus cos squared, the same identity applies, that this will equal to 1. Therefore, all we have is 2 remaining. In other words, those 2 expressions will just add to give us a 2. So we have 6 sine 2x plus 4 cos 2x, and those two added will give us a 2 all over 2 plus cos 2x all squared, and compare that with what we have here, and it matches. So let's have a look at the final part to this question. Find an equation of the tangent to curve C at the point on C where the x value is pi by 2, and write the answer in the form y equals to ax plus b, where a and b are exact constants to be determined. Again, the equation of the line was given in the gradient intercept form. If we look here, it mentioned tangent. So we know that the gradient of the tangent is the same as the gradient of the curve dy by dx at point C. So, and we know that dy dx is worked out in, well, we have kind of shown that this is dy dx. But we need to substitute in the x coordinate of pi by 2 into our dy dx. So this will give us the gradient of the tangent. So we have 6 multiplied by sine of 2 times by pi by 2 plus 4 cos of 4 times by pi by 2 plus 2 all over 2 plus cos of pi by 2 all squared. Again, it's very important that you show your steps. Here you could have just plugged it all in your calculator, press equal and write an answer there. The only thing is, if somehow you manage to press the wrong button and get the wrong answer, by not writing this down and with an incorrect answer written in, you will lose the method mark. So it's very important that you show the actual step that you are pressing on your calculator by just writing them out. This is basically your working out. So if we now simplify this, so again, use the calculator now. So we have sine, the 2's cancel, sine pi is 0, so maybe the top is 0. This is going to be 2 pi, cos of 2 pi is 1, so 4 times 1 is 4, 4 plus 2, we get 6 in the numerator. Cos of pi by 2 is 0, we just get 2 remaining in this bracket, 2 squared is 4, so we just get 6 over 4, which simplifies into 3 over 2. Again, you can simply plug it all in your calculator and get the answer for this expression, but make sure to write down the substitution you've made before plugging it into your calculator. So the gradient of the tangent, or in other words, mt here is equal to 3 over 2. So y equals to 3 over 2x plus c. And we know that the x coordinate is equal to pi by 2. We need the corresponding y coordinate, and we can get this by substituting x over 2 into the equation of the curve, which is given here. So again, that's 3 plus sine of 2 times by pi by 2 over 2 plus cos of pi by 2. So we'll show this the substitution and then work out the answer in your calculator. So this will give you sine of pi. Sine pi is 0, so just going to have 3 in the numerator. Cos of pi by 2 is 0, just going to have 2 in the denominator. So when x is pi by 2, y is 3 over 2. Substitute this into your y equals 3 halves of x plus c. 3 over 2 is equal to 3 over 2 times x, which is pi by 2 plus c. Make c the subject. So c would be 3 over 2 minus 3 pi over 4. So therefore, the equation of the tangent is 3 over 2x plus c, and c is the expression 3 over 2 minus 3 pi over 4. And if you compare this with what we have here, this is the constant a, and this is our constant b. Both of them are in exact form. Thank you for watching. Don't forget to comment on the video, and see you next time.